Good day, everybody. This is Michael, and in this video, I just want to show you how to set up Hadoop in a pseudo-distributed mode. And I'm starting the installation on a bare VM, on a bare Ubuntu 15.10 VirtualBox VM. Now, it doesn't really matter VirtualBox VM. The processes in this video are basically going to be the same. So, I'm a software developer and a big data enthusiast. Also a faculty at desire.com for Hadoop and big data certifications. So in this class, we're going to do installation on a bare VM. The first question is, why are we doing this? Why is it necessary? Why don't we just start up um, one of the numerous quickstart VMs that we have and just get our job done? I'll give you four answers for that. Number one would be learning. Now, to understand at very low level what is happening, sometimes you need to put the pieces together yourself. And that is what we're going to do. We're going to do the configuration ourselves, and we're going to see how it works. Number two is flexibility. For one, I have Cloudera, Oracle Big Data Lite, MapArrow, IBM Big Insight, as well as the Hortonworks sandbox. However, I have set up my own 4-node cluster as well as different installations. Right now we're doing the how-to, starting with the bare VM, and I figured out that sometimes it's more flexible when you put things together yourself. A good example is some of these VMs, they only provide you a terminal shell. So when you start up the VM, you SSH into them and do what you do. And for some people who like to click around and open things and set up their own tools like Sublime, IDEs, they have to do all those on their host machine, put Maven on their host machine, and when they're done with whatever code they're writing, they will transfer the file into the VM and use. Some people are less comfortable with that and want to have a Windows click around and see things visually for themselves. So the third reason would be sometimes in your lab you really want to go beyond Hadoop only tools. You want to use other tools apart from the tools provided in the VM. A good example is you want to use Kafka, and Kafka is not available in the default installation. And trying to install Kafka, you hit a brick of version compatibility. You're breaking some things that exist. No, you want to have your own VM where you put everything together and it works, and you can go beyond Hadoop only tools. Another example would be that you want to try out Spark and Cassandra and see how the communication would be. You have the Cassandra VM and you have a Cloudera VM, but you cannot mix them together. So you create your own lab where you can set up everything yourself and see how they work. A final example would be using a graph database like Neo4j with Spark's GraphX. So you can save a graph structure from Neo4j back and read it from the Spark GraphX. So these are examples where you can go beyond the Hadoop tools you already you have and add them and test them so that when you're making a proposition or making a statement to your colleagues or at work, you know you have tested these things out yourself. The final reason would be just pride and sheer confidence. You have the pride that you can set it up yourself, you know how it works, you're more confident in any position or any decision you're making. Okay, that is it. In this video, we are going to be installing Hadoop in a distributed mode. One reason is we need it for a class that is coming up tomorrow, and where we're going to be doing live display of integrating Apache Flume with Kafka in RAID data injection format. And so for that purpose, I am doing this video and I'm going to set up a Hadoop, Kafka, Zookeeper, and yeah, NetBeans, Eclipse, whichever tools you like. But because it's gonna take a lot of time, I have already done some work ahead of taking this video, and that was installing Java 8 and MySQL. We don't need MySQL for tomorrow's class, but we're gonna do more videos on how to set up Hive and use Yarn or Spark as execution engine. More videos are coming, and So we need MySQL for that purpose, and I just said I should set that up ahead of time. So to set up, to come to this point, this is all I did after installing after creating the bare installation of Ubuntu 5.10. I run this command to just update. Then to install Java 8, you have to add the apt-repository for Java 8. You do update on that, then you run these two commands separately, and you have Java 8. You can confirm the version. So I can confirm the version I have of Java 8 by just opening the terminal window. I say Java version. Yes, I have Java installed. Okay, then to install MySQL, these are the commands I ran, and they'll give you that, so you can also test in MySQL to see that you have a working version of MySQL. So that is that. I had to do this before time because it could take a lot of while running this command. So with this, we're just going to move straight into installing Hadoop. So first you go get the latest version from the website. I use this version 2.7.2, which is the latest. And if you haven't done that, we'll now go to the documentation to see how to set up Hadoop on a single node in a pseudo-distributed format. Pseudo-distributed format simply means that you are in one node, but you are acting as though you are in a distributed format. So the Hadoop daemons run on separate Java processes. So that's what we're going to do. Like I said before, I have downloaded this, so we will just take these files and unzip them. Okay, and also something I did not say is that I have also installed Eclipse and NetBeans. I did that, downloaded Eclipse from the website and NetBeans from the website, and I have set up those tools as well. So because we'll be needing them for development in the class. So having done this, you can just I just copy these files, and I chose to put them in a place that is non-standard, and that is another reason talking about flexibility. I put them in the OPT file. If you take up all these quickstart VMs, you will not find them here, but right now we're doing them right here. Doing them here, that means we can choose where to put things because we want to look for them when we're looking for them. We don't have to check the entire file system looking for files. We put them where we want them, and the good thing is it works and we're fine. I think I have to extract Kafka. So copy to now. If you execute this file like this and just start working, you'll be said to have installed Hadoop in a standalone mode. But what we're trying to achieve is in pseudo-distributed mode. So we're going to go to the documentation for that. Yes, and somehow I missed something during installation, and we're just going to quickly do that, and that will be installing two dependencies for Hadoop, and one is SSH, and the other is rsync. They are requirements from the documentation. You have to install SSH and rsync. Okay, it's where it happened. So rsync, it won't take a while. So haven't done that, I will tell you the reason why. Because in a distributed mode, the nodes talk to the master. They use heartbeat and the ping, and most of these communications, even node to node and file replication, some of them they take this using SSH. And at runtime, SSH requires password, but we don't need we don't have to supply the password at runtime because it is system to system. So we're going to set up a passwordless SSH connection for the system. And to test if we have that already, you just run this command SSH localhost If it requires password, then you know that we're not ready to install Hadoop. So what we're going to do is we're going to run these few commands that we get from the Hadoop documentation website, the Hadoop documentation. We run them in home. We run them separately, and I think I'm going to maximize this so that you can see that. So having run these three commands, we're going to try SSH localhost once again. If we can connect without requiring a password, good. Then we're good to go. That means we can now begin our configuration of Hadoop. We have just copied and pasted the files in this location. So the next thing we do is we start configuring the files. Now to configure, Hadoop is made up of two basic processes. One is storage process, which is HDFS, storage component, which is the HDFS, and the data processing component, which is Yarn. It used to be Hadoop 1, MapReduce before, but Hadoop 2 is called Yarn. So we're going to start configuration from that. We're going to configure. We're going to change values, set values in the core site.xml file. We're going to set values in the HDFS file, site.xml file, MapReduce site.xml file, as well as the Yarn site.xml file. We're going to open them with. Now we're just going to go to the website to get the values for this. So for the core site.xml file, we'll copy this value and core site. Yeah, we're just setting the URI for the file system. Then in HDFS, we're gonna get the file system replication factor. What this means is the number of copies of replicas or the number of replicas for data blocks that should be in the cluster. Remember, we're just doing pseudo-distributed mode, so it can only be one. And in a full cluster mode, it is 3. That means three replicas of the data block for every piece of data will have to be created in a cluster for redundancy. Haven't set this with recommendation from the Hadoop documentation. I'm just gonna go beyond. I want to set some other things differently, and I'll name them. Number one is I want to specify for myself the location where the name node will set up its fx image, the file system image. I don't want that to be set in default location, which is this. I don't know where this is, so I prefer to set it up where I know better. And the name of the value is the property is this. So this is how you can now start changing things to your taste, to your preference. I'll call this Hadoop drive. The folder, the file doesn't exist, DFS, and I'll call this name node. So because it doesn't exist, I'm gonna create this right away. Make directory. So I just specified that. Then second, I'm gonna do the same for data node. We can get that data node from here. Data node. I'm gonna specify data node, and I'm gonna change this to data node. Haven't done that. The default block size for HDFS is 128, but I'm using a small machine, so I want to change what the default block size is, and just finish. So there are tons of configuration that you can do like this. So I'm saying I'm using a small VM with that much size, so I want to use small size to note what the size of my blocks would be like. So just we'll divide what we have right now by 2 to get the size of the block size for this machine. Yes. And that is it for HDFS side. Now, like I said, there are others, other configuration parameters that you might want to take a look at, and if you feel like you can play around with them and see how it works. This is for MapReduce, but it's a template file, so I'm quickly going to save, create the real file itself. And from the website, we can see that we have values to set in here. MapReduce site, we have the name of the MapReduce framework, which is yarn. Now, and for the yarn site, we just have a simple value to set. So, yes, having done this, we now will do one thing. We have to format the name node. Now, the name node is just the name. We have to format the name node and get it ready to accept data. And that command will be Hadoop name node format. Oh, command not found. Yes, I missed something. We have not set a whole list of environmental variables. Now, I have just created a lot of I've created a lot of files in opt/opt, but I have not set them in my path. I have not set them environmental variables, and we missed that point. So we're going to do that quickly, and that will be nano. This is path for Ubuntu, and I already have written them out here. So I'm just going to copy what I need, which is Java, and Bloom, Kafka, and Zookeeper. Okay, Hadoop, Bloom, Kafka, and Zookeeper. I think the versions are still appropriate, but let's take a quick look. Hi, Kafka. This is 11. This is 10, so I have to change this. This is okay. Okay, so we can change the one for Kafka. This is 9. Okay, so we can see that we're good. We can save this file. Yes, source.profile, and so we have it now in. We have configured environmental variables, so we can try now and run that Hadoop command. Good. So we have formatted the name node, and we can now check it and see if we have files in HDFS. Obviously, we shouldn't because we did not put anything there. HDFS DFS ls / now calls from we have an error here that says connection refused from localhost to this. This is a connection issue, and we need to confirm what. Trying to make the call from this, and but we have this set up as this. Okay, one thing to note is that we have not started up DFS yet. So I can remember we have not started. To start DFS, we'll have to use Hadoop home / sbin / start DFS. Okay, so there's a complaint here that Java home is not set and cannot be found. This is going to be an error. Experience has taught me why this happens. It happens sometimes because some of the configuration files just makes life not easy. So I will come to the Hadoop file and see that this is overriding what I have configured as the Java home. So what I'll do is I'll take the value of the Java home here, which I think is correct, and I will replace it here. Now these are some of the things we go through when we do it, and to confirm echo Java home. Yes, that is it. So I save it here, and now let me run that command again. And this time we don't have a problem. Yes, this time we don't have a problem. So our name node is starting, our data node is starting, and I guess also our secondary name node should start. So you can see that in a short, with few steps, we have actually set up Hadoop in a pseudo-distributed mode. Now, if I am too fast for you, you can pause the video and go over the process again. Now, we had an error, and the error led us to know that we had not done something, and that is what we did. Now we can run the DFS command and see if we can still see everything, or if that error still exists. No. So we have data. We have data. So there's nothing in our HDFS. Mind you, you can also access this HDFS link using localhost or your address 5000 and to see the web information of the name node. You can see this is the console, and you can browse the file system locally. You can see data node and a lot of other things you can see using this place. But for now, we'll just move on and try to, if we have some data, we will put them in. So let me quickly just download pg430.txt. Looking for data. We can let's create a folder in HDFS make directory. I would just say make directory called a home directory called raw data. Now if I enter this, it's gonna have a problem because no directory exists, and so the home doesn't exist. So what I'll do is I'll put a -p here, where it will create the entire path, user, current user, and raw directory. So if I say ls command now, ls command, I will see that I have a folder called raw data, and that raw data you will see it as this user/current user hd user. Now this didn't exist before, but this command here created the full path to creating raw data. So we can now put data into this. We can put data into this I want to get something, and so we have a file. We can just download the file. So we have a file in the download folder. We can go to download and md hdfs dfs -put, and you specify pg, and you say put it in raw data user hd user / raw data, or you can just say raw data because raw data is in my home. Good. So if you say ls, if you know the ls, you have raw data as a folder, ls/raw data, you should see what we have copied to. This is a command to copy to HDFS. Now you can do the same thing and browse user raw data, and that is the file we just copied in right now. So remember, we're using 64 as a block size, so the file is in only one block. So we have Hadoop running, and however, we started HDFS, we did not start yarn. So we just run another command to start yarn, and that command will be yarn, start yarn. And yarn comprises resource manager and the node manager. And right now we just run this, we can see that both of them. To confirm that we have everything fine, we can run this command JPS. JPS can just give us all the processes running and their process IDs. So we can confidently say that we have set up Hadoop in a pseudo-distributed mode. Yes, and that is it. So Hadoop is out. Now the next thing we just want to do is set up Zookeeper. If we go to the website, we'll see that Zookeeper. We can see the definition of Zookeeper. Centralized service for maintaining configuration, naming, providing distributed synchronization, and such services. If you've ever written a distributed application where election has to happen, election of a master or a leader has to happen, and you don't want race conditions or deadlocks, you need Zookeeper. We already have the file, we've already kept it there, and mind you, we already put the value, we've already configured what is called the environmental variables, so we can start using it right now out of the box. Once again, you can run Zookeeper in standalone mode. You can run what they call single instance, single node. That means it's one instance of the service running on one node. You can run multiple instance, run on different processes, single node, and multiple instance, multiple nodes. You can read more about Zookeeper and these various types of installation. So I'm going to be doing single instance, single node, and to confirm I have it in my path. Yes, I do have it. We have start. This is what it is to start Zookeeper. Okay, we have to specify the properties file. To specify the properties file, we just have to go configure that. Zookeeper do this. I'll just create another copy of it and rename it config. And this is where you do the configurations you might want with it, and the configuration, most importantly, the data directory. If you want to change this, is okay. This is the default port number, and you have it there. So we'll specify this location, and we can fire Zookeeper right away. This would be Zookeeper home/com/zoo.cfg. Good. So Zookeeper is started in a single instance, single mode. Now it's a lot more involved to do other kinds of deployment, but for the class, this is all we need. Now I'm just going to move over to Kafka. I'll open another terminal in another tab. Kafka actually comes with its own version of Zookeeper. Like Kafka is not in our home yet. Let's say Kafka home echo. Okay, so we don't have Kafka yet configured, so we're just gonna go back to what the class path, and we see it. Exported Kafka here, Kafka home path. Okay, we just have to type source.path. Then we'll run that Kafka again, and we see it. So if we say Kafka, yes, so good. So Kafka comes with its own quick and dirty, as the website calls it, embedded Zookeeper. But I'm going further to install another independent version of Zookeeper. Why? Because I just want to, and number two, because I'm gonna need this Zookeeper installation later when I install HBase, because HBase also uses Zookeeper, and because I'm doing that, and that is why I'm creating a separate instance of Zookeeper. Like the word says here that you can use the convenient script package with Kafka to get a quick and dirty single instance, single node Zookeeper instance. So I am not using it, I'm setting my own, and it's gonna work like we would see. So we have Kafka running, and Kafka is published in subscribed form of distributed messaging. So you have to have a broker, Now in that broker, you have to have a topic. A topic is consider it as the buffer for communication between the producer and the consumer. So to start up Kafka, you have to start up the broker, you have to start up the server, the Kafka server, then you have to start up the broker. Once you started up the broker, the server, you create the topic, so the topic is going to be created. Then you start up the producer to write to the topic and the consumer as well to consume from the topic. In our class, the consumer is going to be an application, and while the producer is going to be Flume. So let's just see a quick example of a quick and dirty example of Kafka in action. So we do Kafka server start. Let's see, it requires a configuration property, and that will be in the Kafka home console. Just establish where the location is Kafka home config, and it will be server.properties. Okay, config server.properties file. So it is started already. So the next thing we're going to do, we have started. I'm going to open another tab, and we're going to create a topic. So we're going to create that buffer that's going to act between that's going to stay between the server and the producer and the consumer. To create a topic, we use the tool Kafka topic. Once again, source profile. So Kafka topic, and what we're trying to do is create, so that to help me keep track of all the commands, I'm just going to do help and do Kafka topic create. What are we trying to create? We're trying to create a topic, replicator factor of 1. Now this is not a Kafka class. I would have loved to explain how replication works. We also have to specify the Zookeeper instance. The Zookeeper instance, which is the Zookeeper we started, is 2181. We have to specify partitions. Where can I get that? Partitions. Yeah, and it's 1. Then the name of the topic, I will call it desired topic. So if you run this command, yes, it's created. You can always find out all you've created by typing list and specify the Zookeeper instance. Zookeeper, the localhost 2181, and that's it. We have one topic. Cool. So we're gonna move now. I'm gonna create different in a new terminal. I'm gonna run the producer in a new terminal. So the producer ought to be an application, but Kafka has a tool for us to create a producer in. Okay, I have to do the source. A console producer. So this is a console producer, and it goes with some parameters, and I just type that so that I can see all the parameters I need. The producer will now be number 1. We need a topic, and the name of the topic is desire topic. What else do we need? We need the broker, list of the broker. We call it the broker list. So broker list. Let me take this up. So the broker list. The broker list is localhost 1992, which is the default the default port number for the broker with ID 0. Now, once you create a broker, brokers have IDs. Remember, I said you can have multiple instances in a single node. So each instance will have a broker ID. Now, the default for broker ID with IDs of ID 0 is 1992. So I just specified that. Let's see what other stuff we need to specify. Can't lay my hands right now on any other thing I need to specify. So I'm just a topic I have specified. I'm just going to say enter. So the producer is ready to produce. So I just copy content from the website and put as content. So the producer is producing. Who is this? Are you producing? So right now we don't have a consumer, but we can create the consumer, a console consumer, quick and dirty console consumer using this tool. And all we need to specify once again is the Zookeeper instance, which is localhost 2181. Sorry, 2181. Then we specify the topic we are listening to, which is the desired topic. I think this suffices if I can remember clearly. Okay, now something happened. So the consumer is ready to consume, but the consumer is consuming from a new offset. That means all the data we added into the producer has already produced into the topic is not seen. So if we type in something new and say hello world, we get it from the consumer. Who are you? So we can see publish and subscribe. So all these previous entries are lost to this consumer. However, we're going to still create another consumer. Now let me take this thing out. The default installation. Let me create another terminal. And sorry, still have to do this. Kafka console consumer. We're going to specify the Zookeeper instance 2181. I'm going to specify the topic, which is the topic. Now we're going to use the word from beginning. That means you let the offset of consumption start from the beginning of the topic itself, and we enter that, and you see we get everything that the other guy missed. The other guy missed all this part. He only had hello world and who are you, but this late comma into the late comma had everything because he had to initialize the offset. So you're gonna know these details when we do more about Kafka. Examples, you can see both of them getting it almost at the same time. So that is Kafka for you. We can see that our installation of Kafka is working. The consumers are consuming fine, the producer is producing fine, and Zookeeper acting in between them is doing just what it ought to do. So we can close this installation. The next one will be Flume. We can set up Flume, but Flume does not require any such configuration, except that you just have to, if you're going to write custom components with Goodwill in the class, you now create a Flume plugin.d folder where you can drop in this stuff. But right now, we can just go and see Flume. Okay, let me copy Flume. I think I have a copy of it instead of downloading a new version. Let media installation. Um, um, okay, so we're just gonna download them quickly. Um, let's film the Apache. Film the Apache, and we're gonna download the latest version, which is this. So, guys, we have been able to install Hadoop in pseudo-distributed mode. We have installed Apache, um, Apache Kafka, Apache Zookeeper, and we've configured them and we see them working. And we're trying to get Flume. Flume is a separate package altogether. But what it's for aggregation of data in a distributed, reliable manner for efficient for aggregating fast-moving data. Fast-moving data. Now we're going to use it in the class, and it's going to be interesting. And we're going to configure it to talk to Kafka, and it's really going to be fun. But right now, to install it, it's just take Flume, extract it, take this folder and put it in that OPT. Then we have to go adjust our manual properties to include a path of Flume. Okay, I already did that, so we can save this and say Flume ng is the main guy. Like I said, we will need this, but I will talk more about configuration in the class. So guys, that is installation of these tools in a nutshell. One thing to note is that we put every file that we created in a certain place. We put every file that we needed in a certain place, which is not what you will get in your quickstart VM. For instance, with the quickstart VM, you will have for the quickstart VM, you have configuration files in the etc folder, but we don't have that now. We have all our configuration files under the OPT folder, and we can play with them. We can change them when we like. We can improve on them. We can add more tools and link them together. And that is it. I hope this video is important to you. If you're going to use this for the class, I will require that you read through, you watch the video again, set it up yourself, and you can see that we have NetBeans and Eclipse, which we're going to use for development of custom components. It's going to be fun, and that is it. See you in class, guys. Thank you.